Bumblebee 3X is a revolutionary vehicle designed to carry out underwater inspections autonomously. My team has iterated on this platform over the past 7 years, and 3X formed the basis of our contract negotiation with an oil and gas operator who is already interested to deploy our vehicle in their field. Why do operators need vehicles like 3X? Firstly, all offshore operators are legally required to carry out annual inspections of their offshore infrastructure. This is currently done by divers or remotely operated vehicles, both of which are connected by cable to a large and expensive vessel. This vessel costs about $50,000 to $90,000 a day, depending on spread of equipment use, and our customer spends an average of $26 million annually just to fulfill this obligation. Other than this high cost, offshore operators also know that every inspection job means sending their personnel out to dangerous working environments. Among all the offshore jobs, inspection jobs has the highest accident rates as the tasks are repetitive and personnel become complacent. BeeX solves this issue by designing autonomous underwater vehicles that can complete the whole inspection job. Firstly, our untethered vehicle comes loaded with pre-programmed missions on exactly what to do. Onboard perception sensors and intelligence allow the vehicle to react to dynamic conditions faced offshore. Secondly, our untethered vehicle do not require much topside support equipment, which means that the boats used can be smaller, cheaper, and hopefully one day, no manned boats will be required. Our autonomous methodology allows the operators to halve the number of vessel days because they can complete the job 40% faster, achieving at least 50% reduction in cost and also the personnel that they send offshore. We have worked on our vehicles for a long time now, and I'm now going to show you and exhibit to you the autonomous features that form the foundational core of this type of methodology. Our vehicles have been tested for its autonomy in the open waters of Singapore and Hawaii. With onboard batteries, we power up multiple thrusters, and with onboard intelligence, we can maneuver and hover in strong ocean currents. With acoustic imaging sonar and optical cameras, we can operate in varied lighting conditions and murky waters. Detection of structures are safely completed, further enabling us to carry out autonomous intervention. To achieve perfection, we use techniques that we have refined over the years, such as turning of valves and accurate live firing into targets. We aspire to be leaders in 3D reconstruction underwater, and finally, our mission is to autonomously launch and recover our underwater vehicles from unmanned vessels. We carry out a comprehensive study of what type of things can be used for inspection jobs offshore. We have many manufacturers that can manufacture tethered vehicles, but all these require the large and expensive support vessels. We then have some manufacturers that can produce autonomous underwater vehicles, but all these are designed with a single thruster, which means that they have limited maneuverability and can only move well in a single line. Among the multi-thruster vehicles, BeeX is leading the way in implementing state-of-the-art AI techniques to achieve movement and maneuvers in complex underwater environments. This market that we are operating in is huge. $4 billion is spent annually by operators on their offshore inspection campaigns, and a further $1 billion is sunk in buying new autonomous underwater vehicles. This market is explosive with a 74% growth rate over the next 5 years. And Asia is projected to take up the largest proportion of work for underwater inspections. 20% of this global market will be here. And BeeX intends to capture $50 million of this market, carrying out shallow water inspections with our vehicles. These are the revenue streams that we will be capturing. Firstly, we will provide 2 variants of our vehicles. The oil and gas operators have a higher requirement, which means that the vehicle needs to come with more batteries and higher spec sensors to operate in their environments. We then move the same autonomy core onto a more economical variant for customers who have expressed strong interest to use this in construction, hull inspection, and search and rescue. These allow them to reduce their reliance on current divers. We also have some customers who spoke to us that they already have platforms and they want us to help them by implementing our autonomous behavior on their vehicles right now. Lastly, we capture recurring revenue by offering maintenance contracts on platforms that we have delivered and software packages as well. This is also augmented by rental of our equipment and personnel. The team behind BeeX is a strong combination of commercial, operational, and technical. My co-founder, Ingwei, has delivered 6 autonomous marine vehicles to date and has a strong research focus on autonomous self-driving. Prior to this, he has 9 years of operational experience managing military units and multi-billion-dollar cap dev budgets in the military. I myself, after graduating, spent 4 years working for the world's largest marine electronic rental company, where I work with many customers that have this demand for underwater inspections in oil and gas, marine, defense, and ocean science. I also know our competitors because I work with them directly. We are supported by a strong academic team led by Prof. Marcelo Ang from the Advanced Robotics Center. He is a leading researcher in the field of autonomous self-driving and supported by a commercial veteran, Prof. William Lee, who has 30 years of experience managing corporate R&D for Panasonic and HP. We have also received angel investment from early-stage VCs who believe in our potential and can form key partnerships with customers that can enable our growth. I hope you are excited to talk to us now and just want to re-emphasize why we are a great business to work with. Firstly, we have a strong business proposition validated by customers who are already willing to pay. Next, we are very passionate about our vehicle and our business, and we have a strong talent pipeline to enable us to enable the company to grow. We are looking for $1 million of funding for growth, and more importantly, strategic partners who believe in our potential and believe in our vision of transforming marine inspections and interventions. Thank you.
Thank you very much. Thank you very much for the interesting talk from Grace. Okay, now we open the floor to questions. Wow, you're very shy, right? Okay, please, the gentleman, the mic, please. Sorry.
Can you share with us? You mentioned that you're aiming for a $50 million market. Can you share with us some color on where you intend to focus your market and the kind of customers that will buy your these vehicles, autonomous vehicles?
So most of the revenue in the early stages will come from vehicle delivery because the price for oil and gas variant is in the millions, like millions, tens, millions. And then we'll also sell the economical version that are about a few $100K, but the quantity for those will be like in tens and 20s. So that makes up the $1 million revenue. And then about 25% will come from the recurring revenue side at the beginning, but this is projected to grow as the customers start to take delivery of more of our vehicles, and then we'll be doing more of the maintenance side.
So you already have a customer that is buying your product?
Sorry?
So, okay, in terms of, actually we have a few customers, I would say, who are interested in the applications that we mentioned just now on oil and gas is a big one. So then we have other areas like search and rescue, construction industry. These are really, actually have customers who are in this area and interested in our product. Yeah.
Okay, thank you.
Any further questions? Yes, please.
Their technology and product looks more like inspection of the underwater inspection. Can you also use it for cleaning purposes, vessel cleaning and all?
Okay, so yeah, we actually had people ask us whether you can do cleaning, multiple customers actually. But one of the challenges in mounting a cleaning device is we're talking about payload capacity, whether the vehicle is actually able to carry the amount of payload. And being battery operator, you have weight limitation and all that. So right now we have not the vehicle is not designed for cleaning. It's really focused on inspection. And we're talking about limited, there will be intervention capabilities, but really mostly focused on manipulation type movement, CP testing, flooded member detection. These are some of the applications.
But specifically towards cleaning, just now I mentioned that we have a second revenue stream coming from autonomy packages. Actually, there are some companies, they have platforms of these cleaning vehicles, but they are all controlled by a pilot. So they have asked us whether, can we embed the software into their cleaning platform. So the revenue wouldn't be coming in by selling them a vehicle, because we think that, we are not people who build cleaning tools, right? But we are people who build that autonomy and then can help them make their vehicle better.
Sure. Thanks.
Any other questions from the floor? Well, I have one question. So Grace and Eng Wei, could you share with us what is the benefits in terms of the cost saving you can offer to your customers when they apply your commercial solution?
So the biggest advantage is that essentially with an autonomous mission, they can save a lot of time in fighting the currents, because all this is already pre-programmed. So the vessel days that is required for a job is reduced significantly, maybe 30 to 40%, and that actually is the cost saver. So they will easily save like 20 to 30K for a 10-day campaign. Yep. And then no operator just do a 10-day campaign. They all have to do like 3-4 months campaign to inspect hundreds of the same structure. Yeah.
Any other question from the floor?
So later, if you visit us at our booth, we actually have a prototype that we can show you. There's on that prototype, that battery life is 4 hours, and then for the oil and gas hybrid, they have requested for the battery life to be upgraded to a 24-hour cycle. So yeah, 24 hours.
So the design for that is able to last actually the entire inspection of a single jacket structure. So we're talking about 24 hours. It will be able to complete the entire thing within that duration, and they can go up, recharge, and then redo the same operation on another structure, which perfectly fits operations of an oil and gas operator. Yeah.
So how's the recharge being done wirelessly?
Wirelessly is something we look into and have been looking into. One of the biggest challenges is being able to charge fast enough. So you may be able to charge wirelessly, but then if you take like 3-4 days to complete the full charge, it's going to be a problem operationally for the operator. Yeah.
And then we also have, we actually, in our design considerations, we understand our waters very well here, like tropically here. The marine growth is very bad. So unlike the North Sea or the US, where they can have like underwater infrastructure charging, all those things, we think that that kind of methodology is probably not so suitable for this area because of the different waters that we operate in. So we implement a different kind of methodology for the support side.
Okay, thank you.
Yes, please. We have probably have time for the last questions.
So what is going to be the direct cost per piece as percentage of the price of the product?
You're talking about the cost of the product versus the pricing that we said?
Cost versus the price, yeah. The margin, basically.
We'll tell you at our booth.
Okay.
Very well. Okay. Thank you very much for the BeeX team. Grace and Eng Wei,